right, we have looked at inverse functions, and we saw that if a function sends the input of x to the output of y, then the inverse function will take y as an input and give x as an output. This is effectively the basis for what a function is, and we have a property called the inverse function property that involves this diagram that will tell us whether or not two functions are inverses of each other. So let's talk about the inverse function property. The inverse function property says that f and another function, which we'll call f inverse, these two functions are inverses if and only if the following two things are true. F inverse applied to f of x is equal to x for every x in A, where A is the domain of the function, and f of f inverse of y equals y for every y in B. And B is the domain of f inverse. So what this is saying is, let's look at the first part, f inverse of f of x. Well, f of x takes x to y, and then f inverse takes y back to x. So if we start with x and we apply f and then f inverse, we get sent here and then we get sent back to x. So we should be able to apply the composition of functions f inverse of f to x and end up with x right back where we started with. And the same thing is true if we start with y. If we start with y and then apply f inverse and then f, so we apply f inverse and then apply f, that should send us right back to y. And so if it does that for every y in the set B, and the first one holds true for every x in the set A, that tells us that these two functions are inverses of each other. So let's take a look at an example and apply the inverse function property to make sure that these two functions are inverses. Let's use the inverse function property to show that f of x equals 5x and g of x equals x over 5 are inverses. So what we're going to do is we're going to look at the compositions both ways here. So we need to look at f of g of x, and we need to look at g of f of x. And we should end up getting x in the end for each of these, so long as these are inverses. So let's look at these compositions. So f of g of x is going to be f of x over 5. And when we apply f to x over 5, we know that f of something is 5 times that something. So this is going to be 5 times x over 5. And the 5's end up canceling, and that leaves us with x. Then we look at g of f of x. This is going to be g of, well, f of x is 5x. So we input 5x to g. And g is the function that takes the input and divides it by 5. So g of 5x is going to be 5x divided by 5, which also gives us x. So because both of these compositions of functions return x when x is the input, we know that these are inverse functions of each other. The example problems in the link below will ask you to go through this process, but you're going to be doing it for more complicated functions. So it's important that you make sure you're careful as you're looking at the compositions of functions to make sure that you end up getting x as your output when x was the input.